What happens to your application when an entire AWS region goes down? And how much data can you afford to lose? So these aren't just theoretical questions. Every production environment will eventually face a disruption, whether it's regional cloud outage, accidental data deletion, a failed deployment, ransomware, database corruption, or even human error. The real question isn't if a failure will happen. The question is, how prepared are you when it does happen? Hi everyone, and welcome back to the channel. This is project 19 of my 100 CloudGuard portfolio project. In this video, I'm going to show you 3 different disaster recovery strategies on AWS. We're going to be working on backup and restore, pilot lights, and warm standby. By the end of this video, you'll be able to architect a disaster recovery solution that matches your RTO, RPO, and budget requirements. But before we start, if this series is helping you prepare for any AWS certification or building any cloud projects, hit the like button, subscribe to the channel, and drop a comment below telling me which disaster recovery strategy your company currently uses. It helps the channel grow, and I read every single comment. Before we touch the console, we need to understand the 2 metrics that define every disaster recovery strategy, which is going to be RTO, recovery time objective, which is how long your business can tolerate being down, and then RPO, recovery point objective, which is how much data you can afford to lose. This is measured in time. Now here is the disaster recovery spectrum. The backup and restore here gives you the cheapest option but the slowest recovery time. It can take hours for both RTO and RPO. Pilot lights can get you down to 10 minutes. It's also relatively cheap. Warm standby gets you to minutes, which means you have a fully functional environment running in a secondary region. And then multi-site active gets you to near zero downtime, which means you have a fully active resources in multiple regions. Traffic is served from all sites, so which means if one site fails, the other site is there as a recovery site. But today we are implementing the pilot light and then the warm standby. Now let me walk you through the architecture. On the left, we have our primary region, which is going to be US East 1. We have an application load balancer, fronting an auto-scaling group of EC2 instances, backed by an RDS MySQL multi-AZ database. We also have Route 53 here to do failover routing with the health check monitoring the primary application load balancer. On the right is our disaster recovery region. We're going to be using US West 2, which is going to be Oregon. This is where the pilot light lives. We have the same VPC and networking infrastructure deployed via CloudFormation. There's an RDS read replica continuously syncing from the primary, and there's an auto-scaling group with desired capacity set as 0, which means no instance is running at the moment, which keeps the cost low for disaster recovery. The application load balancer is there pre-configured, just waiting for targets. When disaster strikes, we flip 3 switches, which we can automate if we want, but for this project I'm just doing it manually. But if disaster strikes, we scale up the auto-scaling group, we promote the read replica here to the primary, and then Route 53 automatically routes to the disaster recovery region. So let's jump to the AWS console and go ahead and view. So here in AWS console, step 1 is deploying our primary stack in US East 1. So the first thing you want to make sure you do is make sure your region is the correct region. So over here at the top right corner, I'm currently in Northern California. Let's go ahead and change your region and make sure you're in the right region for the primary. So we're in the right region now. So we're going to be deploying our stack using CloudFormation. So go to CloudFormation, create a stack, and we're going to choose existing templates and then build and then upload a template, and then next we're going to name our stack the primary stack, and we have a couple of parameters set up already. Our backup retention is going to be 35 days. We're going to be using the dbt3 micro, and our database name is going to be app database, and then the password. This is going to be saved in parameter store. So our disaster recovery region is going to be US West 2. So everything here is going to be right? We'll set up our VPC, our subnets and everything, and then click on next. Go ahead and acknowledge here and then click on next and then submit. So this is going to take about 5 minutes or so to deploy. So this stack is going to be deploying our VPC, our application load balancer, auto scaling group, and then the RDS database. So let's give this about 5 minutes or so. Once it's complete, we'll come back and check the outputs and everything it deployed for us. So one crucial detail you should understand here is this template also automatically creates our AWS backup plan and vault. It configures a daily backup rule with a cross-region copy to US West 2. So as you can see here, we have the backup plan and the role and the selection, the primary vault here. So by just deploying this one stack, our foundational backup and restore strategy is completely handled. And once the stack finishes, we grab the application load balancer DNS name and then the RDS endpoint from the outputs. So here our stack is complete, and these are our outputs. We will need some of it later. Step 2 is setting up the data replication for our pilot light strategy. So for this, we go to database, we'll go to the RDS console in the US East 1. Always check your region, and then this is our primary database created before us by the stack. Select it, go to actions, and then create read replica. And for the identifier, we're going to use the disaster recovery replica, and we're going to use the burst table. We're going to be setting the destination region to US West 1, which is going to be Oregon, and we choose the database T3 micro. And this is an important cost saving strategy here, because a standby replica doesn't need to be as large as our production master, and it doesn't need to be we don't need to set up multi-AZ for it. So right here, we don't need to set up multi-AZ, we can just pick a single AZ. And this is so because we can always scale it up during our actual failover. So we don't need to waste so much money right now setting up. When we're actually failing over, we can just scale it up as we need. For the role, we're going to select our role already created for us, but we leave everything here as default, and then select our single AZ, and then want to come down here, and for the KMS key here, you want to pick on the default AWS KMS key, AWS RDS KMS key, and then go ahead and create the replica. So AWS handles the asynchronous replication for us here. So this gives us an RPO of typically about 1 minute once everything has been created for the asynchronous replication. Now this replica creation may take about 5 to 15 minutes. So let's give it some time to be available. Now, while the replica is being set up for us, we want to go to step 3, which is going to be getting our application code to the disaster recovery region. So for this, we want to go to EC2 instances. Just refresh here. These are the instances created for us for our application. And then you want to select one of them, and then go to actions, go to image and templates, and then want to create an image. And here we're creating an image of our instance and then replicating this image to the disaster recovery region. And we're going to name our image the app server image, and then go ahead and create image. So let's give it a few minutes. If you come to AMIs here, we should see it here pending. So let's give it a few minutes to be available. Once it's available, we'll come in here and then replicate it to the disaster recovery region. Let's go ahead and check our database and see what's going on. We scroll down, it's right here. It's still being created for us. So it's still creating. So let's give it a few more minutes and then we'll come back when it's done. So our AMI is available right now. So let's go ahead and select it. Go to actions, and then we're gonna copy AMI, and then it's gonna be to an AWS region, and then we're gonna select the region, our destination region. So for our destination region, we're gonna pick the Oregon, and then go ahead and copy AMI. Now the copy has been initiated for us. Now to verify this, let's go to EC2 console. But here we're gonna go to the disaster recovery region, which is gonna be Oregon. Come to AMIs, we see it right here being replicated. It's pending. While this is still working, let's go back to our RDS database and then check the replication to make sure it's being created complete. It's still creating, so let's give it a few more minutes. After a few minutes, our read replica is now available. So now we're going to retrieve the endpoint. Over here, come to endpoints, and then we have the endpoint here. Just copy the endpoint. Now step 4 is deploying the dormant disaster recovery infrastructure in US West 2. We're going to run the second CloudFormation template, and then we're going to be passing the copied AMI ID. So here we're going to create a stack. I'm going to grab this template. This is a template here, and then next, and then this is going to be the name. Then we're going to go copy the AMI ID. So let's come over here. This is the AMI ID here. Let's copy the AMI ID and come back and pass the AMI ID as a parameter, and then it's going to be almost identical. Here we're going to get the endpoint for the RDS we copied earlier. So here we're going to pass the endpoint, and then go ahead and click next, acknowledge, next, and then create. Oh yeah, so I mistakenly copied the AMI from the US East 1 instead of the US West 2. So let's come back to US West 2, and then we're going to copy the AMI ID again. I'm just going to go ahead and delete this stack. We're going to create a stack, upload, and here I'm going to just grab my templates, and then next, and then for the AMI ID we're going to copy the AMI ID. Make sure you copy the AMI ID from the US West 2 and then paste it. Everything is the same here. Then we're going to get the RDS endpoint and then paste the endpoint, and then next, and then go ahead and create. This stack builds the VPCs, subnets, and application load balancer. We have no pre-configured target set up already. He also creates auto-scaling group, but the desired capacity is set to 0. So if you come to our auto-scaling group, our desired capacity is 0. This means 0 EC2 instances are running, meaning 0 compute cost for us in the disaster recovery region. He also stores the replica endpoint in SSM parameter store and creates the destination backup vault to receive a cross-region copy from the primary region. So let's give this a few minutes to be complete. So our stack is complete. Now step 5 is going to be the traffic routing. So here we're going to go to Route 53 and create a health check that monitors the primary application load balancer endpoint. So for this, let's go to Route 53 and we're going to go to health checks and we're going to create a health check. Let's name our health check, and then it's going to be for endpoint. This we're going to use domain name, and for the domain name, let's go to our EC2 in our primary region, go to application load balancer. We have our application load balancer here. We're going to be copying the DNS name. Go back to your Route 53, and then it's going to be HTTP, and then paste our DNS name here. Everything here is good, and then let's go ahead and create the health check. Now the next thing we're going to do is we create our DNS records. So for this, you want to go to hosted zones, and to complete this, you want to have a domain name registered already. I have one registered for projects. So click on your domain name and then create records. So for the record name, we're just going to add app, and it's going to come out as app.cloudguard.portfolio.click, and then it's going to be an A record, alias. And then for this, we're going to be selecting our application load balancer. So alias application and classic load balancer. And then the region, we're going to use the first region, which is the US East 1, and then select our load balancer. And then routing policy is going to be failover, and the failover record type, this one is the primary. And then health check, we'll select our health check we created. And then for identification, we're just going to use US East 1, and then add another record. Same thing, app, A record, it's going to be alias. This time we're going to point it to the other region, US West, and then pick our load balancer. The routing is going to be failover 2, and for this is going to be our secondary. Health check, same health check, and then to identify this, then US West 2, and then create records. Let the records create. Let's see the status. So our records have been created. Now the moment of truth, we're going to go through the disaster recovery drill to simulate a real-world primary region failure cleanly. I'm going to run a CLI command to block all HTTP traffic at the primary application load balancer security group. So essentially what I'm going to be doing is I'm going to be blocking all HTTP traffic at the security group of the Elastic Load Balancer. This forces Route 53 health check to fail without destroying any of our actual infrastructure, and we can actually see this health check flip to unhealthy. And to test this properly, we can start a timer and then see how long it takes for everything to fail over to the disaster recovery region. So for this, I'm going to be using Cloud Shell. And here, the first command I'm going to run, I'm just going to set a variable and get the application role balancer primary security group. I'm just going to get that. Here, I'm going to be revoking the security group ingress. Group ID is the primary elastic application load balancer security group on port 80. So I'm blocking everything from anywhere. So just go ahead and do that. Once we do that, let's go to Route 53 to our health check. Right now, it's healthy. If you give it a few moments, it's going to turn to unhealthy because the traffic has been blocked on port 80. So let's give it a few moments and we refresh. It's going to turn to unhealthy. Now, alternative simulations we can do include maybe we could also stop all primary EC2 instances. So if we come here, we can stop all these two primary instances to simulate an application layer failure. Or we could scale down our auto-scaling group to 0 and stop the primary database instance to simulate a complete regional outage. So we can come to our auto-scaling group and we could edit and scale it down to 0 and then simulate a complete regional failure. Also go to the RDS and then stop the RDS instance to simulate a complete regional failure. But for this, I'm just going to use Route 53. So right now it's unhealthy. So right now it should fail over to our secondary region. So from when it's unhealthy here, we can start a timer to see how long it takes for it to fail over to the disaster recovery region. Since we find it unhealthy right now, to manually fail over to the disaster recovery region, step 1 is to scale up the application layer, which is I can run a CLI command to update the disaster recovery auto-scaling group from 0 to 2. And once we do that, instances already start running in our disaster recovery region using the AMI we copied to that region. So for this, let's just come over to the CLI. I'm going to clear. And here I'm setting the minimum size to 2 and desired capacity to 2 in our US West 2 region. So once I enter, and if we go to our instances here and refresh, in a few minutes we should get instances starting to run here in our US West 2. There you have it, 2 instances creating already. And then we can promote our read replica to the primary. So if I come here and run the promote read replica command, so here I'm running the promote read replica command, and then I'm going to promote it to primary. There you have it. This takes about 5 to 15 minutes for the database to become a standalone master. Just keep in mind that during this period, the replica will be briefly unavailable during the promotion, but we can monitor the status. Let's clear again. So let's check the status and see how it's going. So it's still modifying right now, and if you come back over here to the replica and then you refresh, you'll see that it's rebooting, trying to modify. So let's give it a few minutes. It can take about 5 to 15 minutes, but let's give it a few minutes to see how long it takes. So just keep in mind that after promoting the replica to the primary, it's going to get a new endpoint. So we'll have to update our parameter store so that the database can pick it up from there. So this we are all doing manually, but we can easily automate this whole process using Lambda and probably Event Bridge to automate the whole process, changing the parameter store, scaling up the auto-scaling group, and also promoting the read replica. All this we can automate with a Lambda function and also Event Bridge. But for this project, I'm just doing everything manually to make sure you understand and we can time the RPO and the RTO. So let's recheck the status again and see. Okay, now it's available. So right now that it's available, let's go ahead and modify the endpoint in the parameter store. First, let me just set up the variable. Let me get the endpoints, the new endpoints. There you have it. So now let me update the parameter store. So right now I'm just updating the parameter store with the new endpoint. So go ahead and enter and check our database endpoint and say it's been updated. We show value, it's been updated to the new one, which we got right here. So now I'm going to verify DNS failover. Route 53 will automatically detect the primary health check failure that we already saw and then start routing traffic to the secondary record. So now let's just go ahead and verify that. I'm going to use my terminal here to do that. Let's do an NS lookup of our domain. There you have it. We have 2 IP addresses from our US West 2. Now if we curl our domain, we should find it healthy. So now traffic is successfully flowing through the disaster recovery region. And the total time it took me to do this was about 23 minutes. So that's going to be our measured RTO for the pilot light strategy. Now, what if 23 minutes is too slow for your business? We can now upgrade from the pilot light to a warm standby. So we can do so by setting the auto scaling group minimum capacity to 1. So at least 1 instance is always running in the disaster recovery region. So right here now, if I clear my screen and I run this command, we're updating the auto scaling group. In our disaster recovery auto scaling group, minimum is going to be 1, desired capacity is going to be 1. So once I run this, now there is always at least 1 EC2 instance running in the disaster recovery region, already connected to the Replica database. So it's always warm for us in case of anything. If a disaster happens now, my next failover drill will take under 5 minutes instead of 23 minutes it took me now, because the application tier is already warm. The trade-off here is going to be we're now paying continuous EC2 compute cost in the disaster recovery region. And that is the warm part of the disaster recovery, because this is the fundamental architectural trade-off between the RTO and the cost. And this is all based on the business continuity plan of your organization. So depending on what you guys have planned out, this is going to be based on that. But the trade-off here is just you have an application running 24/7 warmed up. So if there's a failover, it fails over evenly. And that is the end of this project. But before we wrap up, let's talk about cleanup. To avoid dependency errors and unexpected charges, I'll encourage you to delete resources in this exact order on the screen. Like I said earlier, we executed the failover manually, but in a mature enterprise, this is fully automated. We can use this. You can automate anything by creating a Lambda function in the disaster recovery region using Python. And then the script does exactly what we just did. It scales up the ASG, it promotes the RDS replica, it waits for the new endpoint, and then updates the SSM parameter store. Then we can also write an event bridge rule that when the Route 53 health check fails, it triggers a CloudWatch alarm, which can first fire an event bridge rule, then executes the Lambda function, and then the entire disaster recovery activation happens without human intervention. And this can drastically drop your RTO to the absolute minimum time required for the AWS control plane. I can include a Python script for that, or I can build another project automating this disaster recovery drill. Now, the key takeaway from this project is that disaster recovery strategy is a business decision, not just a technical one. Your RTO and RPO requirements dictate which strategy you implement. As a solutions architect, your job is to translate those business requirements into the right AWS architecture. If this video brought you value, hit the like button and subscribe to the channel. All the code and the full deployment guide are available in my CloudGuard portfolio. I'm going to update my GitHub repository too. I'm going to put the link below. Next up is going to be the series for my project 20, and this is going to be a DevSecOps project. I'll see you in the next one. Thank you.